Good day all and welcome to this lesson. So on this lesson we are going to learn about trigonometry. So the first thing that we are going to learn about on trigonometry is the trigonometric ratios. Then we are going to move on to the quadrant and try to show how those trigonometric functions operate. Alright, so the first thing about trigonometric ratios is that you should know where to use them. So we are going to use trigonometric ratios only for a right-angled triangle. So this is going to be A, B, and C. So from what we have learned in the past with that, it's easier to say so. What does this mean? It means that for a sine we have opposite over hypotenuse, for cosine we have adjacent over hypotenuse, for a tangent we have opposite over hypotenuse. For instance, if your reference angle theta is at an angle C, this is what we mean. It means that this becomes the opposite side. So we call this the opposite side. Then, since theta is just next to the horizontal line, we call this the adjacent line. So this becomes the adjacent line. And then the longest side is referred to as the hypotenuse. Alright, so by definition, this is what we mean. When we say sine theta is equal to opposite side. So it means this side. It's the opposite side divided by the hypotenuse side. Alright, so this is for sine, trigonometric ratio called sine. And then for cosine, the definition comes as the adjacent side divided by the hypotenuse side. So it means the the adjacent side, which is CB, over the hypotenuse side. So using the letters, the opposite becomes line AB, hypotenuse becomes AC, line AC. So these little lines that you saw there at the bars, they indicate that it is a line. Therefore, for the adjacent side, you have BC, line BC divided by line AC. And then we have the tangent. So tan theta is opposite over adjacent. So it's the opposite side over adjacent side. So the opposite side becomes what? Line AB divided by line BC. Alright. Now that we have learned about the trigonometric ratio, there is another thing that we should also learn about, which is called the Pythagoras theorem. So the Pythagoras theorem says that when you add the opposite side, the adjacent side, squared, they should give you the hypotenuse side squared. This is what we mean. It means that opposite side, let's say AB, line AB squared plus line BC squared. BC squared is equivalent to the longest side AC squared. Alright, so it means that if we had to represent this in a Cartesian form, We know that the vertical side is, we normally refer to it as the y-axis, and the horizontal side we express it as the x-axis. So now, if we look at AP would have been y squared plus BC, it's the horizontal side, becoming the x squared, and then AC, which is the longest side, becomes your r, which is the r squared. So basically, this is just what the Pythagoras theorem. Just to recap, remember that when you want to solve a right angle triangle, you can either use the trigonometric ratios plus the Pythagoras theorem. Are we together? I think it all explains everything very well. Now let's move on. Now we move on to the Cartesian plane. So in a Cartesian plane, we are going to use a mathematical way of doing things to plot this Cartesian plane. So we can still also refer to it as x, and then here also as y. However, now we are going to use the degree. This becomes what? A 0 degree at the beginning. It becomes a 0 degree, and then we will have a 90 degree, 180 degree, and then we have 270 degree, and then after completing the revolution, we have 360 degrees. This we refer to as the first quadrant. So in the first quadrant, we have A. A refers to all. What we mean by all? We mean all the trigonometric ratios in the first quadrant, they are all positive. Why are we saying they are positive? We are saying they are positive because on this side of the x-axis, everything is positive. And also going here, everything is positive. And then we also have your r, which can represent radius, meaning that it's also positive. Meaning that your opposite side, your hypotenuse, as well as an adjacent, it's positive. That is why everything in the first quadrant is positive. So we refer to cos theta positive, sin theta positive, tan theta positive. Are we together? Now let's move on. We come to the second quadrant. So in the second quadrant, this is what is happening. You can tell that this is your origin, isn't it? Now, moving horizontally to the left, everything this side, you have a negative x. What does this tell you? It tells you that the adjacent side is negative. The adjacent side is negative. So it doesn't need a further word of explanation. That goes to tell you that cos and tan will be negative because the adjacent side is negative. So in this side, you have cos theta being negative, tan theta being negative, and then you have sine theta being positive. Let us explain why do we have sine theta as positive. Alright. Sine theta becomes positive because now, remember, the opposite side, let us just have a smaller unit diagram and have our theta there. So the opposite side here, it is still positive, meaning the y-axis is still positive. Now, if you look here, the opposite side is still positive. Are we looking for any adjacent when we refer to the sine? No, we don't need it. We just need the opposite side as well as the hypotenuse, which is always positive. Hence, you find that the sine is positive in the second quadrant. Let us move to the third quadrant. So here we have the third quadrant. So on the third quadrant, we have the adjacent side being negative, the opposite side being negative. The only thing that is positive in this side, it is what? It is the hypotenuse, which is the longest side. The reason why you find that tan is the only one that's positive, it's because the opposite side is negative, the adjacent side is negative. Negative divided by negative becomes a positive. And we have tan theta as the only function that is positive on the third quadrant. So we have positive tan theta, negative sine theta, negative cos theta. Still together. Right. Okay, now we move on to the fourth quadrant. In the fourth quadrant, we have the opposite side being negative and then the adjacent side being positive. What does that tell you? The opposite side will affect sine because it's opposite. It will also affect tan because it has what? The opposite, which is negative. Now, this tells you that cos is positive. Why? Because the adjacent side is positive and hypotenuse is what is always positive. So we have positive cos theta, negative sine theta, negative tan theta. Alright. Okay. Now it's time to introduce the reduction formulas. Now, with reduction formulas, we are only going to operate with only 3 for this level. So this includes for level 2 as well as level 3. Now, on the first quadrant, we only have theta. On the second quadrant, we have 180 degrees minus theta. Why are we saying minus theta? It is because we are still below 180. Hence, we are saying minus the acute angle that we refer to here. Now, you are now moving beyond 180 degrees. When you move beyond 180 degrees, you are going to say the reduction formula there is 180 degrees plus theta. Are we together? Let us move. Now, we come on the fourth quadrant. On the fourth quadrant, what do we have? We have something less than. So it means we are just below 350. It means that the reduction formula becomes 360 degrees minus theta. Okay. So the example that we have here is of the trigonometric function sine. And what can we interpret is that we are given sine theta equivalent to opposite side being 4 and then hypotenuse being 5. We are also restricted in where we should plot this diagram. If it says that 90 degrees, between 90 degrees and 180 degrees, that's where our angle of theta should be. It means that we are from here, it should be between 90 and 90 degrees. That means it should be in the second quadrant. This is what we are going to do. We are going to illustrate this thing by drawing it like that. So, this is not 90 degrees, 180 degrees. That means now it's between 90 and 100 as given by the example. So now, this is what we are going to do. The opposite side is equivalent to 4. The hypotenuse side is equivalent to 5. Alright. So the question says that determine without the use of a calculator, you must find a cos theta and tan theta. This is what you must determine. Alright. Okay. So what we are going to do is that normally in the exam they will say determine this in terms of ratios. In terms of ratios. Now, the first thing that we need to do is to find what? The adjacent side. How are we going to do that? We are going to do what? We are going to do a Pythagoras theorem. Here is a Pythagoras theorem. It's y squared plus x squared being equivalent to r squared. What are we looking for? We are looking for the x-axis. Hence, we are going to leave x squared as the unknown. So, we have x squared plus, what is y? Y is the opposite side, which is equivalent to 4 squared equivalent to 5 squared. Now, we are moving everything to that side. We having what? This is 5 by 5. It's 25. This one becomes 4 by 4. It becomes a 16. Therefore, we are having what? We are left with 9. This is your x squared, and therefore your x. You need to be very careful. Because now it's on the negative side, your answer was going to be plus minus 3. However, we have been restricted. Therefore, it is only minus 3. Alright. Now, by definition, cos is equal to x over r. What is the value of x? It's minus 3 over 5. What is tan? Tan theta, can I put the theta here? So tan theta is equivalent to y over x. What is the value of y? The value of y is a 4. What is the value of x? It's minus 3. Therefore, this is tan theta. So, this is how you would go about solving this problem. To further illustrate the reduction formulas, we are going to do an example. So the examples will be in such a way that you have to write the following as trigonometric ratio of theta. So number A, let's look at number A. So number A, we have cos 180 degrees plus theta. The first thing that we do, we look at what? The reduction formula. Where do we find this? In which quadrant is 180 plus? It is in the third quadrant. Now, in the third quadrant, we only have tan as positive. So, that would mean that this is equal to negative cos theta. Why? Because cos is negative in the third quadrant. And then we move on to number B. To number B, we have 180 degrees minus theta. So that means we are now where? In the second quadrant. Because that is where 180 minus is at. So that is where it is at. Okay. Alright. So, sine 180 minus theta is at the second quadrant. In the second quadrant, we have sine as positive, hence we will have what? Sine theta. Next. Then for number C, we have tan 360 minus theta. So 360 minus theta, it is here, it's in the third quadrant. So in the third quadrant, tan is negative. So we have tan theta. So basically, that is what we are having. Now, let us have a look at the same type of a problem. If you look there, we have a problem which is given. So on this problem, it is said that you should simplify the following expression to a single trigonometric term. So you have to solve this to a single trigonometric term. So what you are going to do is the same as you had applied on the above example, whereby you had to write the trigonometric ratio in terms of theta. Now you are given 360, and let's have a look at this example type of a problem. It says that sine 360 degrees minus x multiplied by tan 180 degrees minus x. Everything is divided by cos 180 plus x multiplied by sine squared x plus cos squared x. Alright, now let us go to solve this problem. 360 minus x is in the fourth quadrant. The fourth quadrant sign is negative, therefore we have sine theta multiplied by tan 180 degrees minus x is in the second quadrant. In the second quadrant, we have negative tan x. Apologies, this is supposed to be sine x. Alright, now 180 plus x is in the third quadrant. So in the third quadrant, cos is negative, therefore we have cos x being negative. Sine squared x plus cos squared x. How are we going to manipulate this one? Let us go at the back of the question paper. Now, at the back of your question paper, you will see there you have equation 22. It is given that sine squared theta plus cos squared theta is equivalent to 1. Therefore, here we know that sine squared x plus cos squared x is equivalent to 1. So you just multiply by 1. Now, according to the trigonometric ratios, sine x over cos x is equivalent to tan. Now, negative divided by negative is a positive. Now, we have this tan x multiplied by negative tan x. This is this. This is there. Multiplied by 1. Therefore, we have negative tan squared x. Remember, the question said you should answer this, you should give this to one trigonometric function, and we have found that it is negative tan squared x. Still continuing on the exam type of the problem. Now, here we are told that we should prove the following identity. Cos divided by 1 plus sine x as the denominator plus 1 plus sine x as the numerator divided by cos x as the denominator should be equivalent to 2 divided by cos x as the denominator. So what are we going to do? We are just going to say the left hand side. Then what are we going to do? We are going to find the lowest common denominator. The lowest common denominator, which is 1 plus sine x multiplied by cos x. Going together. Alright. So, this is it. For our denominator, we have 1 plus sine x cos x as the denominator. This goes there, this goes there. Cos x multiplied by cos x plus 1 plus sine x. This one and this one is 1 plus sine x. Right. Okay. Let us manipulate and solve the numerator. Looking at the numerator, this is cos squared x plus We are going to use the FOIL method, same way as we've been doing to solve for x, because we have what? 2 brackets. So 1 multiplied by 1 is 1. Sin x multiplied by 1, it's sin x. Then 1 multiplied by sin x is equivalent to 2 sin x. Then sin x times sin x is equivalent to sin squared x. Everything will be 1 plus sin x cos x. Alright. Cos x squared sin x squared. It reminds us of equation number 28. So on equation number 28, as given, sin squared theta plus cos squared theta is equivalent to 1. Therefore, this and this is 1 plus 1 is 2. Therefore, we have 2 plus 2 sin x. Everything is 1 plus sin x cos x. Okay, let us look at the denominator. We already have cos x. Yes, cos x. Now let's try to manipulate the numerator. So the numerator, we take out the common factor. We have 2, 1 plus sin x. Everything divided by 1 plus sin x cos x. This divides with this, therefore we have 2 over cos x. Therefore, the left-hand side is equivalent to the right-hand side.